Okay, so compute the value of the secondary voltage, the voltage per turn of the primary, and the voltage per turn of the secondary of the ideal single phase transformer below. So we are to compute the value of one, the secondary voltage, and then voltage per turn of the primary, and then the voltage per turn of the secondary. Okay, so we have our diagram. So this diagram represents an ideal transformer. Okay, so we have our primary side and then we have our secondary side. So we have V in, which is the primary voltage, or V1, which is the primary voltage, which is 120 volts, and then N1, that is the primary number of turns, is also what, 1000. V2, which is the secondary voltage that we are to solve for, and then N2, which is the secondary number of turns, which is also 500. So this is our diagram. So before we start with the solution, please you make sure you subscribe to my channel. Okay, so first of all, let's put down our data. So we have N1, which is the primary number of turns, is equal to 1000. N2, which is the secondary number of turns, is also 500. Then our V1, which is the primary voltage, is equal to 120. V2, which is the secondary voltage that we don't know, we are going to solve for. Okay, so our solution A, which says we should calculate for the secondary voltage, which is the V2. Alright, so we use the voltage transformation ratio, which is N1 over N2 equals V1 over V2. So we are to solve for V2, which is our secondary voltage, and to do that we cross multiply. V2 multiplies N1, then V1 multiplies N2. So we have V2 times N1 equals N2 times V1. So we make V2 the subject. So how do we do that? We divide the left hand side by N1, then we divide the right hand side by N1. So we have V2 times N1 over N1, then N2 times V1 over N1. So N1 cancels out. So now our V2 is going to be N2 times V1 over N1. So we substitute the values. So we have 500, which represents N2, times 120, which represents V1, all over 1000, or 1000, which represents N1. Okay, so when you multiply 500 by 120 and you divide by 1000, our answer is going to be 60. So our V2, which is the secondary voltage, is equal to 60. Let's move on to solution B, which says we should calculate the voltage per turn of the primary winding, and we use the formula V1 over N1 since we are calculating for the voltage per turn of the primary winding. So when we substitute, we are going to get 120 over 1000, and when you divide 120 over 1000, we are going to get 0.12 volts per turn. Okay, so let's move on. So now we solve for the voltage per turn of the secondary winding, and that one too we use the formula V2 over N2. So when we substitute, we are going to get 60 over 500, which will also give us 0.12 voltage per turn, or V per turn. Thanks so much for watching.